misconception is the assumption that some of the materials used for the prefabrication of 3D modules, which we call volumetric units, 2D panel systems, often referred to as flat pack systems, components and assemblies, are somehow different in comparison to those used for traditional construction. The materials are exactly the same as those as you would expect to see on any other building site. The key differences between the in-situ and prefabrication approaches are accuracy and quality control, with, in the case of the latter, elements of the building being quality checked and tested off-site before being assembled rather than built. It is structured around the following four main material headings: timber, steel, concrete, hybrid. A little bit of history to begin with. The Forbidden City in Beijing was built during the 15th century using prefabricated timber frame components that locked together without the need for nails. The first prefabricated timber systems used in the UK were probably the cruck or crook frames used in the Middle Ages for houses, medieval halls, and tithe barns. This part of the module looks at the characteristics, performance criteria, and systems fabricated from sawn timber frame, mass-engineered timber, MET, composite panels. Sawn timber is used extensively as the structural material in open, boarded one side only, and closed 2D panel systems, and for structural components such as roof trusses and roof cassettes. Closed panels can be fabricated with interior and exterior finishes, insulation, windows, doors, and some MEP components factory installed. Sawn timber is commonly used for non-structural infill framing and partitions in volumetric models. It was, for a time, the most common form of 3D volumetric module construction, but this is no longer the case with a shift to steel. Strength, shrinkage, and fire performance characteristics limit the use of STF in buildings of more than 6 or 7 stories and spans greater than 6 meters. Fabrication, handling, and transport restrictions are the only constraints limiting panel dimensions. Vertical panels evenly distribute loads along their length, consequently they are best suited to buildings with a cellular layout that is repeated vertically. Roof cassettes are usually pre-finished and insulated, fabricated with some composite timber components to achieve 14-metre clear spans. The maximum permissible height for the use of timber in the exterior walls of a residential building under current building regulations is 18 metres. Around 25% of new low-rise houses in the UK are built using timber frames. Engineered timber covers several different products with different characteristics. Insulated timber, CLT, is a manufactured structural two-way spanning solid wood panel product used for the primary structure, floors and walls, of buildings and volumetric units produced by stacking and gluing between 3 and 7 layers of timber, known as lamellas, at 90 degrees to the layer below. Panels are up to 24 metres in length and 2.95 metres in width. The tallest CLT buildings in the world are currently around 18 stories, however this cannot be achieved in the UK under current building regulations. Research into the fire performance of CLT by Cambridge University defines the material as self-extinguishing. It chars but does not burn, remaining structurally sound and intact. CLT structures are inherently stable, as they are assembled and castellated and interlocking panels fixed together with wood screws. Building services do not require special fixings, so site noise levels are relatively low in comparison with other forms of construction. Nail laminated timber, NLT, is similar to CLT but, as the name suggests, nailed rather than glued, which means it can be prefabricated almost anywhere and does not need the major investment of manufacturing facility. Veneer lumber, LVL, is sometimes described as plywood on steroids. LVL is formed from multiple layers of thin wood assembled with adhesives. Due to its composite nature, it is much less likely to warp, twist, bow, or shrink than sawn timber. Its strength is comparable to glulam, but with higher allowable stresses. Timber, glulam. This is another manufactured product formed with layers of parallel sawn timber laminations glued together under compression to form structural beams and columns. The greatest advantages of glulam are its strength compared to sawn timber, and that it can be manufactured in a wide variety of sizes, configurations and shapes, for example, curved and tapered. Fabrication and transport restrictions are the only limitation on the length and weight of the components. Like CLT, glulam is described as a self-extinguishing material. Structural insulated panels, SIPs. This is an alternative to sawn timber with a layer of insulation material sandwiched between two layers of orientated strand board, OSB. The panels are manufactured in two thicknesses, either 142mm or 172mm thick, depending on the U value required. Panel width and length are constrained by the maximum dimensions of the OSB at 1,220mm wide by 7.5 meters long. Although these panels are structural, they are frequently used as the inner leaf or exterior walls as fast, cost-effective means of enclosing a structure.
Stewart Milne Timber Systems, one of the UK's leading timber system designers and manufacturers. Its group factory in Witney, Oxford, is in the perfect location to serve all regions of the Crest Nicholson Group. The advanced timber panels are constructed with 140 by 38mm softwood timber studs that are nailed together following the integrated CAD/CAM system. The design information is fed directly into the cutting and nailing machines. To achieve current building regulation standards, 100mm of foil-backed polyurethane insulation is carefully cut and then placed between the studs of the timber panel, therefore making sure all spaces are fully filled. A 9mm OSB sheathing board is then applied to the frame to provide rigidity to the panel. This is nailed into place and provides a backing to the reflective breather paper, which is added next. UPVC windows and doors that have been supplied directly to the factory by the approved window supplier are fitted to the timber frame panels on sliding brackets. This means they can be transported within the depth of the panel and don't waste space. On site, they can be slid out easily into the correct position. The timber floor components are all pre-cut, assembled to form cassettes, and then flipped over. Chipboard finished flooring is used to deck the panels, and all joints and screws are covered with a protective tape. Integrated lifting slings are incorporated so they can be easily manoeuvred and dropped into position on site. Finally, the advanced timber frame panels are lifted onto the transporter and taken to Arborfield.
For construction in every form is an eco-friendly material when sourced from renewable sources. With appropriate consideration of the different characteristics, the various products can be combined to form low-carbon developments. The greater accuracy of pre-manufactured systems and panels results in better quality and consistency in finished buildings. Fire compliance and sound attenuation must be carefully considered, particularly for residential developments with the height restriction for the use of timber in external wall construction and/or cladding. Cross-laminated timber and laminated veneer lumbers as a solid component are excellent material for sound attenuation, which is more of a challenge for timber frame components requiring careful consideration. Cavity barriers are a vital compliance element of every building. They are particularly important for volumetric modular construction, as there is a gap almost all the way around the modules, except for open-sided modules.